Hello, and welcome back to Biodiversity Impact, a podcast exploring the journeys of scientists, sustainability experts, entrepreneurs, creators, and others who are working towards a more nature-positive future for people, planet, and profit. I'm your host, Bez, and today I'm very excited to be outside of the podcast studio in a very special place indeed. We're currently at Danum Valley, a conservation area and field station surrounded by primary pristine tropical rainforest in Sabah, Malaysian Borneo. You might be hearing some cicadas and frogs and birds in the background during this interview. Today I'm very excited. I'll be interviewing Dr. Martha Ledger. Martha is an Earth observation scientist interested in investigating emerging environmental, ecological and social issues and has been conducting research in this field since 2017. She's currently a postdoctoral fellow at the University of Hong Kong School of Biological Sciences. Hello Martha, how are you today? Welcome to the podcast.
Hi there Fez, it's great to be here and really excited to talk to you today.
I'm so happy that you agreed to do this with me, thank you. I'm really curious to find out, what is it that you do as an Earth observation scientist? Can you tell us a bit about your background and what brought you into this field?
So I think it all began from a very young age. I had a real curiosity with maps to begin with. So I remember in the early days, my first book was a Kingfisher Atlas, and I just remember poring over the pages, which sounds like a very corny origin story, but it's absolutely true. And that went forward onto doing a geography degree and picking up Earth observation and remote sensing as a skill. And I just realised that through Earth observation, I was able to observe so much about the Earth and processes and how it works, and it's just really snowballed from there, really.
I have a similar experience with looking at maps especially, and seeing specimens in museums and looking at their labels and thinking, oh, that says, Sumatra, where is Sumatra? And then going to a map and seeing where it is. It's so far away from the UK. And
yeah.
At that young age, it feels like really amazing to see those faraway places.
Yeah, exactly. Yeah, and it's great to be able, and an absolute privilege to be able to do it as my job, really. So I feel very, very fortunate. But my day-to-day is mostly spent looking at imagery or data, typically from satellite remote sensing. So that could be simply from images or optical imagery, or creating structural data from LiDAR or radar. And a lot of this is sadly very much computer-based, which, is nice, but I like to make sure that I complement all of these observations with getting out into the field so I can help contextualize the measurements that I am making on the ground. And therefore it's a real privilege to be here in Danum Valley and to understand the forest structure and to really understand what it is that I could be measuring from Earth observation.
So tell us what the differences are when you are getting data from satellites versus getting data on the ground. Do all Earth observation scientists come into the field?
Great, yeah. So this is actually something that I'm quite passionate about emphasizing, because Earth observation data is so readily available. You're able to capture regional dynamics really simply through freely available data, free tools that we're able to analyze this data with. But it's really important to have that localized understanding of having been in the field. So there's a real spatial mismatch in what we're able to observe from space compared to what we're able to understand on the ground. So for example, from say satellite remote sensing, we can get a really good idea of the regional dynamics of the canopy and canopy structure, but we really don't know all that much about the structure of vegetation from the ground and all of the microtopography and microscale differences. And so it's very important to make sure that we collect data to contextualize what we're observing from space.
Could you tell us a bit more about how you've taken this passion for ground truthing Earth observation data?
I was testing out a new method of INSAR, so that's interferometric synthetic aperture radar. It's basically repeated radar measurements. so that we can create a time series for surface movement of the ground. And this was over tropical peat swamp forests at a particular site called the North Selangor Peat Swamp Forest on Peninsula Malaysia. And this method had regional scale potential to be able to monitor the subsidence of the peat that could have been occurring there from a lot of the drainage for agriculture, mainly oil palm and rice paddies. But in order to be able to test that this method actually worked, I had to be situated out in the field for around about 10 months in total.
Wow.
And I was setting up a network of subsidence poles, which is basically you have to get loads of poles which you anchor into the substrate beneath the peat so that you ensure that the pole isn't moving, and that the peat surface should move relative to the stable pole. And therefore you can measure the change in the surface height of the peat.
And this is due to fluctuations with water?
Yes. So peat is, for anyone who doesn't know, it's a very highly high organic content soil. It's very carbon rich. I believe the statistic is that for a 1 hectare plot, there is 20 times more carbon storage potential within tropical peat soils than a typical primary forest.
So much.
Huge potential. The way that it is made is from being waterlogged, so that prevents any oxidation from occurring. So all organic matter that falls within the peat bog ends up being preserved and stored as carbon. But if we were to lower the water tables through drainage to produce land suitable for agriculture, then all of that organic matter becomes oxidized, and we see huge pulses of carbon being lost from these peat into the atmosphere. So yeah, an important system to be able to measure, and equally important that I had those ground measurements in place, because overall my PhD was inconclusive. I wasn't quite able to prove that this INSAR method was capable of accurately detecting the rates of subsidence across the area, but it was a really great experience to show that what you observe from space doesn't necessarily correspond with what's going on the ground.
Super interesting stuff. So, as you've just said, you've been working to ground truth your Earth observations with fieldwork. And so working in Earth observation science must be both inspiring and demanding. What keeps you motivated in this space?
I feel motivated in this space because it is so dynamic. I'd say that my research interests are evolving in that I've realised the capabilities of Earth observation for being applied to so many different problems in the world, or investigating emerging issues. So I've had experience utilising Earth observation products to produce forced labour risk maps, which I was super interested in back working at the University of Nottingham Rights Lab. I'm currently, I've won a grant recently which is helping to detect pathogens that may be prevalent in penguins in Antarctica.
Wow.
And so I've realised the capabilities of using Earth observation to map where penguin colonies exist each year and where they breed through penguin poo. Turns out you could detect penguin poo from space because of the pink colour.
Wow.
So
amazing.
Just realising all of these cool applications really, really excites me. With that, we're able to actually understand whether colonies return to the same site every year. We could also potentially estimate the number of penguins that exist in these colonies based on the size or expanse of penguin poo that we're able to detect. So it's not something that I ever imagined that I'd be applying my Earth observation skills towards. But yeah, really, really interesting.
Really creative.
Very creative. And not only that, I think we're at an exponential point of data collection through Earth observation data, to the point actually where there is so much that we don't know what to do with it. And so I'm actually quite excited by the emergence of AI in particular, with its capability for deriving meaning very quickly from all of this big data that we have access to. So that's what keeps me motivated. There's a lot of exciting things that are already happening and already coming on the horizon.
And what you say about how we organize this data is going to be our next challenge. I mean, we're no longer sort of stumped to find methods for collecting data. It's actually the way we curate the data and make it findable and accessible and reusable that is going to be our next big challenge for big biodiversity and big Earth observation data.
Definitely. Right? And it's such a common topic amongst so many scientists on our field, irrespective of the discipline.
Yeah.
And it's something that I understand that business really wants to be able to pin down and quantify in a meaningful way. And so therefore it's really important that we're talking about things like this to find a way to standardize all of this data and make common sense of it for everyone to understand.
Yes. Of course, Martha, no journey is without its obstacles. What are some of the key challenges you've faced in your work?
I'd say a key challenge is that I feel like the practice of Earth observation and remote sensing, because of how easy it is to conduct from a desk, and also how cost effective it is with so much freely available data and methods, I worry that the discipline has become somewhat lazy in that it's a very fundable discipline because it's very powerful in terms of its data collection and analysis capabilities, and it's effectively free. That means it's very easy to fund, but it means that we're producing data that isn't informed by what's actually going on the ground. And I feel like my PhD is a really good example of that, of how the patterns we thought we were seeing with the radar weren't actually occurring with what we observed on the ground. So I'm on a real mission to ensure that anybody who is trained in Earth observation and remote sensing to make sure that they are conducting the field work to ensure responsibility for the products that they're making out of this data.
I've noticed in business white papers and not-for-profit organisations that, such as the Nature Tech Collective, who are doing a lot of work analysing what technologies are contributing towards a biodiversity positive future, that they're saying, you know, maybe Earth observation, yes, it's a gold standard, considered a gold standard in businesses for quantifying and reporting on biodiversity impacts and dependencies, but there is now an understanding in this sector as well that we have a biodiversity data gap and things should be ground truthed.
Definitely. And I completely agree with it being a gold standard method because it has so much potential. With so many revisit periods of satellites, like with global coverage. But yeah, proof, and it means that it's even more important that ground truth data is incorporated, because if there's going to be broader impact of being incorporated into business strategy or even government decision making, it has to be founded on proper ground truthing to ensure that you've got a responsible product.
So, Martha, looking ahead, what are your thoughts on the future of Earth observation science?
I have a lot of thoughts about this, actually, and a lot of complicated thoughts. I'm optimistic because of the sheer amount of interest of Earth observation in many sectors. It's becoming more and more of commercial interest. So previously we've been very dependent on government-funded missions such as Landsat or through the Sentinel systems that came through the European Commission. But more and more there is private investment for very specific purpose satellites being launched. And more now governments are realizing the commercial capability for Earth observation. They're seeing this as an opportunity to cut their own funding in their provision of Earth observation science. So whilst governments might think that's a good idea because it will cost them less, it means it's less likely that this data will be publicly and freely available in the future. So that's something that concerns me. Another thing that I guess I'm optimistic about is we have great potential for AI to be used to make great meaning of this data, which I touched on before. We're already seeing examples of where AI is able to screen imagery immediately to detect objects of interest, depending on what that object of interest is. And because of its high capabilities, we're able to derive meaning from imagery faster than ever. When I was training to do this 15 years ago, the process of even cleaning a single image to make it to derive meaning and processing it would take months and months and months.
Wow.
And now I'm at a stage with cloud computing where I'm able to produce time series or products in a matter of hours.
Wow.
So there's huge progress in what we're able to derive from Earth observation imagery in that respect. And so I'm quite excited to see how it's going to be incorporated into many, many disciplines in the future.
Just the sheer time difference that it takes to create such a big amount of work.
Yeah. But obviously there's caveats too. With all of this proliferation of data and Earth observation missions, there's actually a huge environmental impact that we need to consider with the field. There's this website that I quite enjoy browsing. I can't remember the name. I can provide the link in the show notes. It visualizes all Earth observation satellites or debris from rockets or that have been used to launch these into lower Earth orbit and beyond, and it just shows you how littered and populated our lower Earth orbit is with satellites and debris, and it's becoming a very cluttered space, and I know there have been efforts by the European Space Agency to try and derive methods to retrieve old satellites that are no longer in operation. It's something that's become quite concerning. And even on Earth, in order to store all of this data in huge cloud computing facilities and data centers, the carbon footprint of that is massive. What's needed for air conditioning, for example, in order to be able to keep these facilities at appropriate temperature. There's huge consequences for our data and our online footprint, if you will.
Yes.
And that's something that I think about quite often, of how we could make the sector more sustainable.
It's really interesting. It does just take such a huge amount of energy to keep them running.
Yeah.
And then what happens if they're not running?
Precisely.
Our societies are so dependent upon them now for so many parts of our lives,
Yeah. And if you think of all of this exponential data being produced and the backup for all of that also, it's massive. So something we really need to think about and be concerned about.
Masses and masses of data. So what gives you hope, and what should we be paying attention to in this space?
What gives me hope is that I feel Earth observation has always been quite a niche discipline which has failed to really bridge the gap between ecology, biodiversity, many disciplines, even in the social sciences. But increasingly I'm seeing that gap being bridged, which I think is really exciting. I think it's really important for young scientists to be trained in skills in both, and so that we're able to make meaningful products and data out of what we can get from Earth observation. So that gives me a lot of hope, particularly being on this trip with all of these brilliant students and seeing their capabilities and how multidisciplinary they are actually has been very impressive. Their skills in data analysis, being able to understand spatial statistics relative to their curiosity about the plants and animals we're seeing here in Danum Valley, that fills me with a lot of hope. And paying attention to, I think we need to be keeping a close eye on ensuring that the data remains freely available and freely available for analysis through freely available products. That's a really key cause of mine.
Yeah, important to have open biodiversity data and open science.
Absolutely.
And as you said, currently in Danum Valley, we have taken the opportunity to quickly record an episode for Biodiversity Impacts, but we're supporting the undergraduate field course from Hong Kong University in tropical ecology and global change. And students, as Martha said, have been really inspiring to work with, and we do what we do for the future generations to benefit from, and passing on that knowledge is super important. And one more thing that you said was being connected to the ecosystem. I think this really demonstrates that we do need to actually come into the field and experience the complexities of ecosystems in order to, if we're back in the lab doing Earth systems, to be thinking in both those dimensions in that multidisciplinary way.
For sure. I have spent months at a computer. And whilst I do enjoy what I do, so much of it is contextualized by being out in the field, and I'm feeling really inspired and excited to get back to understanding what I've seen here, back at a computer again. It's great to have the two to be able to balance out the understanding of where we are.
Well, this has been a really educational conversation, Martha. Thank you so much for taking the time to chat with me today.
Thanks for having me, Fez. It's been a pleasure, and a pleasure to be here as well, and to have met you this week as well. It's been fantastic.
It's been really, truly fantastic. Thank you so much.
Thank you.
I really hope you found today's conversation interesting, inspiring, and insightful. If you like the podcast, please do subscribe on Spotify, Amazon Music, YouTube, or any other place you get your podcasts. Thanks again for listening, and I'll catch you in the next one.